Hello, my name is Tyler Bell, and I will be doing part one of the Ansys Fluent project for fundamentals of aerodynamics, EAS, check the course code, EAS3101. Uh, so you first start off in Ansys Workbench. You drag and drop Ansys Fluent into the workspace workbench. The first thing you're going to do is you're going to set up your geometry. For this one, open new design modeler geometry. Down here in the bottom it says starting design modeler. That means it's running, and you just got to wait for that to clear, and it'll open a new window like this. Normal to the z-axis. Go to sketching. We're going to rectangle of dimensions. We need our height, we need our length. Our length in this case, oh, actually, first things first, convert your units, make sure they're in millimeters. First thing, or after that, your length, in this case it's 150 millimeters, and height, 10 millimeters. Zoom way back in, because I accidentally had meters. So this is what we need first. Once you have your rectangle drawn, you go to concept and you take surface from sketches, click on any one of the lines. Over here on the side where it says base objects, click apply. You'll see it turn teal, click generate. It fills it in with the gray. And that's it for this portion of the drawing. So you can close out of this window. It closes, and then you can go to mesh. I like to just right click on mesh and then click edit. Once again, saying starting meshing, and it'll pop up a new window. And there's the part from earlier, right? We'll go back normal Z. And so we need to create our mesh. First thing, you see the mesh off to the side underneath projects. Right click on it. You go insert and you go to method. Automatic method. Click on your gray surface, your rectangle from earlier, and then click off to the side where it says scope and then geometry, no selection. Click in that yellow box and click apply geometry. We'll turn it blue and you click generate. And what this has done is it's generated a mesh. This mesh is way too coarse for what we're trying to do in this project. So we need to refine it and make it a whole lot finer. So you right click mesh again, you click insert sizing, and you click up here where it says edge. You can also hit Control E, and then you hold Control and select two edges. So I click the top and bottom. I'm going to apply them to the geometry. You get the yellow bars on it. What we're going to do is we're going to change element size to number of divisions. We have 150 millimeters long. Let's just space them out. We'll do 150 divisions. So I'll space it out all the way along nice and even. We're going to take capture curvature and we're going to turn it to no. We're going to take behavior, we're going to turn it to hard. So that will give you, meshing when you click generate. It's done. And click back on mesh. You can see, we're a bit smaller. We still have some weird issues, but it's now lined up the entire top and bottom for meshing. What we're going to do now, just still want it even finer. We're going to go sizing again. We're going to do it off of the inlet and outlet. Apply the geometry again. Type. We're going to change number of divisions. This time we're going to do 100, so that there's more of them, so you can see that boundary layer throughout the whole simulation. We're going to change capture curvature again to no, behavior to hard, and click generate. And it's done. So if I click back on mesh, it's pretty clean in the middle, but on the edges, move it on over. You can see that it's all kind of messed up still. We want that to be clean and uniform. So what we can do with that is, if I zoom out, you go right click on mesh, insert, and you do face meshing this time. With this one, it's like the first step where you did the automatic mesh. You just click on the surface, you click apply geometry, and click generate. When this one's done meshing, you should see it's not actually turned the whole thing black. It is a very fine mesh. And this way we can really get a good look at the boundary layer and the developing region for this simulation. After all this is done, you need to name your different parts. So you click back on the edge, and you start with top wall. Just click on it, left click on it, and then just press N, and it'll come up with selection name. So I'm gonna name this one top wall. Do the same for the bottom wall. This front one will be inlet, and the one towards the rear is going to be outlet. All right, and click generate just one more time, just for good luck and good measure. But that's it. That's all you have to do in this meshing portion. So you can close out of this window, and then you see how there's a little lightning bolt next to it. It means you got to click on it, and you have to click update. That means there's been a change done, and you have to update it to then be able to go on to setup, and then eventually go on to solution and results. If you don't do this, you'll have to go back, and it may mess things up later down the line. All right, so now setup is ready to go. Click on it, right click, click edit. We're gonna do double precision, and I have a decently beefy desktop, so I'm able to do this. If you don't have a beefier machine, just go with the default settings. It'll run, it'll take it a little bit longer. Okay, so it's in now. The model is in. I didn't have any issues coming in through the console when it was booting up. So that means we're all set, and we can start putting in all sorts of different parameters for this simulation. So first thing we're going to do is we're going to go to model, click the little drop down. You're going to go over to viscous, and it's SST K omega. I'm going to right click on that and click edit. I'm going to change this to laminar because that's what the project specified, and you click OK. That's all you need out of model, so you can close that. Next thing is material. We're going to do a fluid. I'm going to do air. However, to get a Reynolds number that will maintain laminar for this internal flow, I have to change the density to 1, and I have to change the viscosity to 0.001. This will spit out a Reynolds number of 750, because we'll show later on, the free stream inlet velocity is 5 meters per second, and the overall length we know is 150 millimeters. So they'll give you a Reynolds number of 750. So, but once you have your properties in, you click change/create, press it again just to make sure it worked. Hit close. You're now, once you're done with that, you can close out of materials. You can go to boundary conditions, click the little drop down, or you can just double click on it. Bottom wall isn't going to do anything. It's stationary in this one because we have the Poiseuille Couette flow. So the bottom wall is stationary, so we don't have to do anything with that. We can click close. At our inlet, however, we have a free stream velocity coming in at 5 meters per second. We don't have, any sort of additional values, just we're given this 5 meters per second. So we can apply, we can close. We go to outlet, and all we're double checking on outlet is that it is a pressure outlet, and we'll click prevent reverse flow. Basically, it's saying that at the outlet, it's going just to the atmosphere. And if you prevent the reverse flow, it's going to basically say that nothing from outside is going to flow inside into this tube. If you don't click it, you may get some odd results at the end where it's saying that air from outside the system is now coming in. So just click prevent reverse flow and you'll have clean looking flow throughout this whole thing, and basically assuming that like the pipe continues on indefinitely beyond our outlet. We'll click apply, okay, close. We'll go to top wall. Now this is the one that does change, since we do have the it's a combined of the Poiseuille Couette flow, so we do have a moving wall. It is moving in 3 meters per second in the positive x direction, so 1 on the x, 3 for the meters per second. We can just click apply and close, and that's all of our boundary conditions set. So we don't have to do anything else with those. Double click on reference values, however. You are going to compute from the inlet. And this is another place where you can go and like change some of your values. So, you know, if you want to change your density or, you know, temperature, the viscosity, velocity, anything like that, you can do it also from these reference values, instead of having to go back through materials or model or materials, you know, boundary conditions, all sorts of stuff like that. So this is all looking good. And what we'll do now is we'll go down to initialization. We'll just click initialize and it will run through 10 iterations. It won't show us anything yet. It just does this to initialize for the actual calculation itself. So once it initializes, you double click on run calculations, and we'll run 500 iterations. If you run too few, like if you only ran 1 iteration, you may have your residuals may be too high and you may not get accurate results. If you run too many, you may achieve accurate results at fewer iterations, so now you're just wasting computation and time. So, you know, 500 seems like a good number. I didn't optimize this number, so this is just, you know, it seems like a good number just to get decent results out of it. But once that's, you know, set up, click calculate, and you'll see it start running. It shows this lovely little graph, but it disappears quickly because it ran so fast. So calculation complete. We can click OK. If we want to look back at this graph, we can look at scaled residuals. You see where residuals are dropping off. Didn't necessarily plateau off, so I probably could run this for even more iterations. But I don't, like I said, I didn't optimize it, so there's no way of knowing how many iterations may be. Actually, no, you can figure it out. I just did not because it doesn't specify. So that should be all in this portion. So you can, I'm just going to minimize this window in case I need to go back to it. Now we're done. We can move on to results. So for results, you're going to click edit. It's going to pop up this window, full screen it. We'll go normal to Z, and we just get this empty wireframe, right? Just minimize those. So what we need to do is we need to get a velocity profile at the midpoint, at the endpoint, but we also need to find our maximum velocity and our pressure gradient and stuff like that. So before I put in any sort of contours or vectors, I'm going to go to this little drop down called locations, and I'm going to start with a line, and this is going to be our midpoint. So what we're going to do is we're going to take this and we're going to go out to, remember, so now this one's in meters. So you do 0.075, 0 for x, 0 for z, 0.2, 0.075, and our y, 0.01. This will create a line, will pop up a yellow line, roughly right here in the middle. In our line type, we're going to put in sample, and we're going to sample 100 times, right? Just going to click apply, and there it is. Our little yellow line pops up. You know, we did it right. So we also need to do one at the endpoint. So we'll name this one endpoint. Click OK. So for this one, we don't want to put it exactly at the end. You want to put it ever so slightly before the end of it because it's technically cutting off exactly at the 150 millimeter mark. So I'm going to do this one at 0.1499. So 149.9 millimeters from the inlet. And then once again, for the second value, 0.01. Samples, we're going to do 100 again. So we're going to click apply, and you see that little yellow line right over there, really close to the end, but not exactly at it. So that's good. The other thing too, if you want to zoom in on a specific region, just hold the right click button and drag. You'll see the little plus magnifying scope come up, and it'll create this red rectangle, and you can just release it and it'll zoom into that section for you. Obviously your standard movement of, holding control, pressing down in the center mouse, you can move it like this. You can rotate it by scrolling on the mouse wheel. Zoom in is just no control scrolling on the mouse wheel. But we'll just pop back to our normal. So we have these two set up. What we can do is if we go to point, we'll call this one max the velocity, if I can spell it correctly. Click OK. We're going to do this as a variable maximum. We're going to do this on symmetry 1, or we'll actually do it on surface body. So it's anywhere in here, we're looking for the maximum of a variable, and our variable in this case we're going to say velocity u. So that's velocity in the x direction. And if we just click apply, we get our big old crosshair way out here. Oh, forgetting the movement system. All right, so there's the crosshair. It's putting it directly at the end. We can move it inwards later if we want, but we're just going to leave it there for right now. So first thing we can set up is, let's do a velocity contour. Velocity contour. Click OK. So domains, all domains, location, we'll do it on symmetry 1. So whole big green area. Variable, we're going to change this to velocity u, right? We only care about the x direction because we don't have any y velocity. And if we just click apply, it'll run it, and we get this, you get your legend popping up, and then you get your flow. Hide these so I don't see them right now. Then you can see just the velocity contour, right? If you want to move the legend out of the way, you just right click up on legend, you click edit, you can go variable location. I'm going to change it to variable. I'm going to move it over to horizontal, and I'm going to change the aspect down to 0.02, and we'll bump the size up to 0.7. Right? Click apply, it puts it up there now. Right? But the thing is, though, if we're looking at our velocity contour, go back to it, the transition, it's fine, but it's a bit choppy. We could get it a little bit smoother, and that's all because of this number of contours value down here. It's only at 11, so we bump it up to, let's say, 50, we get it a little bit smoother. We bump it up again to, say, 150, even smoother. I like to put mine just right around 250, get a decently smooth transition. You come in, I can't really see the lines, maybe a little bit there in the middle, but I'm not really too worried about it. So this is our velocity contour. The next one we can set up is we can set up a pressure contour. Right, just click OK. Once again, we're going to do this on symmetry 1. Our variable will be pressure, arrange global, and we'll start off with just a number of contours at 11. Right, we'll just click apply. And if we just uncheck the velocity contour, it'll hide it, and we'll just see our pressure contour. So this is it. Once again, kind of choppy with the colors. So I'm just going to bump this back up to the 250 I did for velocity. Smoother transition now. All right. So from here, we can plot our velocity profiles. Actually, no, first we'll do the velocity vectors, right? We'll call this velocity vector. Vector. All right, click OK. We'll go location, symmetry 1, sampling. We'll leave it at the vertex. This is just going to be at the intersection of all of our meshes. So wherever those vertical and horizontal lines crossed, that's a vertex, and that's where each one of the arrows and the vector arrows will be coming from. If you do it face centered, it'll do it from the center of the rectangles that we made, etc. We are going to do go to vertex variable velocity. It's fine by me. Projection, and if I click OK, I hide the pressure contour. If I zoom way on in here, you can see them, but it kind of just looks like a mess right there in the middle. So what I'm going to do is I'm going to change these. Where do I change them? Symbol. Oh, here it is. Symbol. It's a line arrow right now. I like the 3D or arrow 3D. You can still see they're way too big, right? Like you can't see the ones in the middle. Granted, down here at the bottom, you can see them pretty well, but you go a little bit up and instantly they all just mush together. So what we can do is we can change our symbol size down. So if I bump it down to 0.5, you can see that the arrows have gotten a little bit smaller. I'm going to go 0.1. Actually, we'll bump it up just a little bit. 2.5. No, we'll go 0.15, right? Crossing over a little bit in the center, right where the maximum velocity is going to be at. But down here at the bottom, there's still some of the ones at the very edge are a bit too small to see, but for a majority of the boundary layer, they're actually a good size, so you can see them without them crossing over and going nose to tail. So if we go back to here, right, kind of hard to see them if you do it like this. However, you take your velocity contour, right? You zoom on in, you can still see them. They're the same color. They also have the same amount of transparency. So if you click Edit, you go to Render on your velocity contour, you can change your transparency. So if I bump this up to 0.75, I click Apply, now I can see my velocity contour in the background, while also my velocity vectors in the foreground. And if I hide the contour lines as well from the velocity contour, it just kind of shades in the region behind it. So just a little bit easier to see what you're looking at. So then after hiding the contour lines, you can kind of get a cleaner look of your boundary layer. So you can see here, I move it around a little bit, kind of zoom out. You can kind of see it tracing on up to the middle. This is on the bottom plate, so it's stationary. So down at the bottom, obviously we have 0 velocity, so stationary plate. However, if we go up to the top, we can see a different velocity profile because it's actually starting with an initial velocity of 3 meters per second. So slightly different, but that's because it's the Poiseuille Couette flow. So those are your two different boundary layers. Back to Z. So I'll hide both of those right now. I'll just leave the pressure one up. No, we'll bring it back. So now what we can do is we can graph our velocity profiles at the midpoint and the endpoint, right, at our two yellow lines. If you go to graph, you'll call this one velocity profile, and we'll do, we're inserting a chart, which is this little chart looking diagram right there. Click OK. We're going to do an XY line. Title, we'll call this velocity profile. We go over to data series. We have series 1. We'll call this one midpoint. In our location, we will choose midpoint. On our x-axis, we want to do velocity u, right? We want the x velocity. On our y-axis, we are going to change it to y because we want the height. So if we were to, once we graph this, we see our velocity profile. So this is the overall height of or the distance between the two plates. This is our x velocity. So then, as you can see, if we look at the chart, we can see that on the top plate, we're moving at 3 meters per second, or the flow is moving at 3 meters per second, which adds up since we set the top plate to be moving at 3 meters per second. And the bottom plate moving at 0, it's a stationary plate. So now if we go back to data series, if we click this page with the little star on it, it'll create us a new series. We'll call this one end point, location, endpoint. It'll save the X and Y, and we click apply. Location missing. Oh, did I miss it? Yeah, I did. Endpoint, we click apply. And if you look at it, it is overlaid it exactly onto the midpoint one, which tells us that the midpoint is after the point at which the flow fully develops. So if we go over here under report and click the drop down next to velocity profile, click it next to the midpoint and endpoint. If you deselect one of them, you'll only see one of the graphs. If you select both, you won't see any. So that way we can get a good look at our midpoint velocity profile and then also our endpoint velocity profile. I'll leave them just both up. Down here at the bottom, if you want to go back to where we started, you go back to 3D viewer. So now, we need to figure out where our maximum velocity is, or we need to know what it is, and we need to figure out the height at which it happens in here. So if we go to calculator, you go to, nope, not calculator, function calculator, yeah, function calculator, you go to symmetry 1 for your location, and you choose your function to be max value, your variable to be velocity u, right? If I just click calculate, it'll give us a maximum value 6.85532. However, since I set up earlier the maximum velocity point to be at the point of max velocity, right? Hence the name. If I click calculate, right, we see same value, just way on out there. But what we can do now is at this location, we can change our variable to be y. And if we unclick clear previous results on calculate, click calculate, we see maximum velocity or maximum value of velocity u on max velocity is this. But we also get the y value. So we know that our maximum velocity is 6.8554 meters per second at, what is that? 5.7 millimeters from the bottom of the wall. So it's just above the midplane, the midpoint distance between the two plates. And if we actually look at our chart viewer, looking back on these, right, we can see that right at this dash is 0.5, and we're at the peak of this, we're getting pretty close to 0.06 or 6 millimeters. So it all kind of lines up. We can export this value later on to an Excel sheet. It'll be a .csv, and then you can take that and graph it in Excel and do some Excel math with it if you like. So now if I go back to outline, we need to do the pressure contour. So for this one, you have to go to variable, you right click and you click new. We will call this, or we need to do pressure gradient, sorry. This will be pressure gradient, and we click OK. Our method will be gradient, and it'll be just gradient of pressure. We click apply. It'll create a new folder, user defined, and this is this is our value, or does the math and figures out what it is. So now we can create a contour. We can call this a pressure gradient contour. Click OK. So we want this one to just be on symmetry 1. Our variable for this one, since we created a variable last time, we can click pressure gradient. Global, we can set number of contours. We'll just set it to 11 right now. We click apply, and we'll hide the velocity contour and the velocity vectors. This is our pressure gradient contour, right? We can see at the entrance, we're getting higher pressure gradient, and then through the rest of it, it's pretty much all the exact same. So, once again, we can increase our number of contours. We can bump it up to 50, have smoother transitions, and we can see that it extends a little bit further out than where the first graph of only 11 contours was showing us. So let me double check. I have everything. Velocity contour with vectors, pressure contours, show velocity profiles at mid and end section of the pipe, determine max velocity and height at which max velocity occurs, determine pressure gradient using Fluent results in theory. You go to calculator, you go to function calculator, you can do max value. You can do it at system symmetry 1 variable. Since we set up that earlier, you can do pressure gradient. You click calculate, and you can figure out maximum value of pressure gradient on symmetry. So we can get that value. If you want to know the exact location of it, you go and you click location. You do a point. You can call this max pressure gradient. Click OK. Method will be variable maximum, location. We'll do it on, we can do it on symmetry 1, pressure dot gradient, and we click apply, and it puts out a little crosshair for us right out here. You can see that's, judging off of the contour, we can see that's where it should be. If we go back to calculators, we go to here, we can change the location to max pressure gradient, and we can change our variable to x. We click that, and we can see a maximum value is happening like really close to the edge. And then if we click Y, click calculate, it's happening at 0.2 millimeters up. So this x value can basically just be assumed to be 0, considering it's to the negative 17th power. But so we can take those values as well. If you want to export any of them, we can go back to. So if we go to File, you click Export. I'm going to change the file location. We're going to move it into Ansys Fluent project. You can see some of the test stuff in there. Max Velocity Fluent project, we'll click Save. If I open up that folder and I find where it went, did it not save it? I have to click Save here. Click Desktop, we go to Classes, Spring, Fundy. And there it is, Max Velocity Fluent project. Open it up, click Convert, it's fine. So if you see right here, it gives us our velocity and our x, y, z. Our z doesn't really matter because we're only doing this in 2D. So I just like to delete this column because it isn't needed. If it lets me delete it, there it is. And I don't really need this x data because it was set up to be at the very end. What I care about is this y value and the velocity value. So I can save those for later on. But I believe that is all. So we have pressure contour, pressure gradient contour, velocity contour, velocity vectors. This is kind of more of a visual bug where it does stuff like this. If you zoom in, it fixes it. If you want to export your the velocity profiles, you can, we'll change the name of this. We'll call this one midpoint velocity profile. We'll change our location to be midpoint, and we will still keep our velocity u. You click save, you go to the Excel file, you open it up. You can then graph the velocity versus height. So then you can have it in Excel or also in chart viewer in here. And that should be it. Once you get all the data and everything, you can then put it into a report. But yeah, thank you.